Okay, so this is the review for the um, Unit 5 test, which is on Chapter 6, I believe. Yes, no, hold on, let me double check that. Yeah, because we skipped Chapter 3. So, let's look at some multiple choice questions. In order to set premiums at profitable levels, insurance companies must estimate how much they have to pay out in cars. So remember, the formula for the expected value is the mean of x, which is the sum of x sub I, p sub I. So all we're going to do is we would go 0 times 0.6 plus 500 times 0.05 times 100 times 0.3 plus 2,000 times 0.2. And so if we do that, we get the expected value of C is 595. The correct answer is B. Remember, you can also do this in your calculator. You can put the values in L1, the probabilities in L2, and then do a one variable stats using the L2 as the frequency, and it'll get you the expected value and the standard deviation. Okay, next problem. All right, so I'm going to pause this, read the problem, then we'll go over the answer. So this question is asking, what exactly does expected value mean? And the expected value would be that on average, they would pay out that $595 for every car they insure of this model. So that answer is D. And if the company insures a large number of cars, they can expect the average cost per car. And that's taking into account the law of large numbers. This would be the standard deviation. And this is the thing they know they will. That's why A is wrong. So pause this, read the question, and then we'll give you the explanation. Okay, so let's look at this real carefully. So the key expression is the students that describe a discrete random variable. So we would measure this for each subject, and at the end of it we would put a probability of getting each one of these. So this is discrete, and this is discrete. VO2 is not discrete. It's a continual scaled thing. It's not going to be a discrete random variable. So the answer is C, 1 and 3. All right, read the question, pause, and we'll pick up the explanation in 1 second. Now we have a continuous random variable, and so that assume that x is normal with a mean of 240 and a standard deviation of $60. So the probability is approximately 0.6 that a randomly selected week Dan will make less than. So it's a normal distribution, so we need 0.6. So how we're going to do this one is we're going to do an inverse norm. Let me make sure I set that up correctly. Hold on. Okay, and so the way to do this is there's two ways. One is you could find the z-value and solve, or you could use your calculator. And so if you use your calculator, we're going to go to clear that. What we'll do is we will go to distributions, and we'll go to inverse norms. Area is 0.6. Now remember, this is the only place you can get into trouble with this. Remember, the calculator, if no direction is given, gives less than or equal to. But that's what we were asking for, is we wanted the probability of this value or less. If we wanted more, then we'd have to do 1 minus the area. And it said the mean was 240, and the standard deviation was 60. No, that's not what I wanted. Dang it. I was in the wrong place. Sorry. So second distribution, inverse norm, 0.6. There we go. We're already there. Everything's already set up. So I click paste, hit enter, and we get 255. So that's our answer. Now you can also do it doing z-values, but I think it's easier if we just do the inverse norm on the calculator. So we'll put that off to the side and we'll come back to that. So the answer was C. All right, a result of a single roll of a 6-sided die with a result of a 8-sided die, then the mean of A and the standard deviation is this, the mean of B and the standard deviation is this. Let D be the difference, then which one of the following is true? So the mean D will equal the mean A minus the mean, B minus A. So mu D will be 1, because that's just 4.5 minus 3.5, so the mean of D equals 1. But the standard deviation, even though we're subtracting, excuse me, is we still always add standard deviation. So, and we don't add standard deviations, we add variances. So sigma D equals sigma squared D equals sigma squared A plus sigma squared B. Even though we subtract it, we're still going to always add the variation. So this is going to be sigma squared D equals 1.71 squared plus 2.29 squared, and so to get sigma we would take the square root of both sides. And so the only one of those that works, and the answer is C. All right, so read this question. And let's see here. So we have a linear transformation. A vending machine operator has determined that the number of candy bars sold per week by a certain machine is a random variable with a mean of 125 and a standard deviation of 7. His profit on each bar sold is 25 cents, and it costs him $5 per day to maintain the machine and rent space for it. So it's a linear transformation. So mean P is going to be 0.25 times 125 plus 5. So mean P is, this should be minus 5. Right? He has to pay for that, so it's subtracting 5 from his profits. So we get a mean of 26.25. Now sigma D is going to be 0.25 times 7. But in a linear transformation, we do not subtract. We don't do addition subtraction in a linear transformation of the standard deviation. And so it's just 0.25 times 7. And so I should get a standard deviation of 1.75. So the answer to that one is E. All right, it has been estimated that about 70% of frozen chickens are contaminated with enough salmonella bacteria to cause illness if improperly cooked. Chickens are delivered to the grocery stores in crates of 24. Assume that chickens are independently selected for inclusion in the crate. The probability that the crate has more than 4 contaminated chickens is so this is a binomial probability. Step on my mic cord there. And so what we have is it binary? It either has a salmonella or it doesn't. It tells us, it says to assume they're independent. It says it in the problem. There's a fixed number, and that in case will be 4. And then the chance of 6, it's 30% each time. So this is the probability that X will be greater than 4 is what we're trying to find. So you could do this, use it. You can find the probability of 3, the probability of 2, the probability of 1. I'm sorry, K is not 4. K is 24. So there's 24 trials. So the easiest way to do this is to remember the calculator will only find less than or equal to on this. So what we'll do is we'll do a binomial CDF. Trials is there's 24 chickens in each crate. The probability that it would be infected is 0.3. Our X value is 4. So this is going to be 4 or less. And we get that. But if we look, the question asks is what would the chance that we would have more than 4? So we're going to go 1 minus our answer, and we get that. So our answer is C. It's been estimated, same problem. The mean and standard deviation of the chickens in the crate is. So we have our formulas. On our formula sheet is for binomials, expected value is n times p, and the standard deviation is the square root of n times p times 1 minus p. So this is just 0.3 times 24. So, and that's, all right. So that's going to give me 7.2. And then my standard deviation is the square root of 24 times 0.3 times 0.7. Which is 2.24. Uh-oh, I already had the answer on here. Sorry. So read this problem. Which of the following random variables is geometric? So remember, geometric was bits. Binary, independent. We keep going till we get a success. And the chance of success is the each time. And it's success till the first time. So A is the number of phone calls, no. B is the number of times it's successful to get 2 5s. No, it's not till the first success. The number of 7s in a row, nope. The number of digits I will read at the randomly starting point in a table of random digits until I find a 7. How far do I have to go until I hit a success? The Census Bureau reports that 27% of California residents were born outside the United States. Suppose that you choose 4 Californians independent of each other at a random. Let F be the number of foreign-born people in that group. So now what we're dealing with here is we're dealing with a binomial probability. So f equals 1 would be probability that x equals 1 is 4, 1.27 to the fourth times 1 minus 0.27 to the third. Or you can just put it in your calculator. You get the same answer either way. I should write that out, and this is a free response, so I should write that out, and then I can write my answer out, and I'm all okay. So then we can just go to our calculator here, bring it up, and I can do distribution. Now it's a PDF because it's a single trial. 4 trials. Probability of success is 0.27. Number of successes is 1. And I get 0.420. So 0.420. So the probability that you would get greater than 1, I could either do a binomial CDF of 1 or less, or I could find the probability of f equals 0, add those together and subtract it from 1. Either way, we're going to have to subtract from 1 to do that. So I'm going to do the binomial CDF of f. Hold on 1 second. Whoops, I'm sorry, I didn't read this carefully. This is not the probability of greater than 1, it's the probability of greater than or equal to 1. So the easiest probability to do is to find probability the f equals 0, and then just do 1 minus that. And you can do that in your calculator, and you will get an answer of like 0.7160. So find and interpret the expected value of x. So for binomial distribution, the expected value of x is the mean of x, which is just n times p. So that's going to be 0.27 times 4, or I can't do that math in my head, it's 1.01. So that's the value. So interpret. If we selected 4 people at random multiple times, I'm not going to write this down, you're going to have to do it. Actually, here, why don't I just give you the book? Here. Oh, it's going to be like that, is it? Okay, so you would say the long-run average of the number of foreign-born residents in a randomly selected group of 4 is 1.08. So now we have to find the standard deviation. So the standard deviation is the expected value, the sigma x equals the square root of n times p times 1 minus p. And so that's going to be 4 times 0.27 times 1 minus 0.27, and we're going to take the square root of all of that, and I would get a value of 0.888. And so the expected average distance between the number of foreign-born residents in a random group of 4 and the mean number is about 0.888. All right. An IRS employee starts to randomly select forms one at a time to check for mistakes. What is the probability that the first form with mistakes is the 7th one she checks? Hold on, I'm missing some information. There we go. So the IRS estimates that 8% of all taxpayers filling out long forms make mistakes. So this first one's a geometric probability, right? Because it's how many until we get a thing. And so So we would say the formula for geometric probability, once again, I'll write this on the board if it comes up on the test. So the formula for geometric probability is that, because if it was given on the AP exam, but we can just do it in our calculator. Here, I'll show you guys that. So you would just go, sorry, I gotta keep bringing the calculator up. You would just go geometric point, p-value is 0.08, x value is 7. So our answer is there's a 4.8% chance. Okay, so let's do the second one. This one promises to be a little trickier. Same RS employee announces that lunch one day that she checked 25 phones this morning and didn't find mistakes on any of them. Is this surprising enough that her supervisor should worry about whether or not she's missing errors? So the probability of no mistakes. Probability of no mistakes. So now we have to do, what's the probability that one will not have a mistake? Well, that's going to be equal to 1 minus 0.08. But it didn't happen once, and we're assuming independence here. It's going to be that 1 minus 0.08 to the 25th power. So if you do that in your calculator, if you do that in your calculator, 1 minus 0.08 to the 25th power is about 0.12436. So should the supervisor be surprised? I mean, it's unusual, but it's not below that 5% threshold that we stress about. So it's not uncommon enough that the boss should be concerned. All right. All right. Let's look at one more problem. The weights of adult men are normally distributed with a mean of 190 pounds and a standard deviation of 30 pounds. So A, if you randomly select 3 men, what are the mean and standard deviations of the sum of their weights? So the new mean is easy. That's just going to be 190 times 3. Because it's 190 plus 190 plus 190. So the new mean, the mean of 3 adults is that. But the standard deviation of the 3 adults is tricky. Because what it's going to be 30 squared. It's going to be the square root of 30 squared plus 30 squared plus 30 squared. Because we do not add standard deviations, we add variances. So you could also do 3 times 30 squared. That'd be fine. And if we take the square root of that, we get 0.51.96. Sorry, I don't know what happened there. So that's A. So an elevator in a small apartment building has a maximum weight of 700. If 3 randomly selected go on the elevator, what's the probability they expect their maximum weight? So we have a normal distribution with a center 570 and a standard deviation of whatever, and so this is going to be like 570 plus. So 622 is going to be there. So 700 is going to be about there. So we want the probability of that or greater. And so what we would do is we would call up our calculator here. Oh, my calculator's way down here. and we would do second distribution normal CDF. Lower limit is 700. Upper limit's infinity. Mean is 570. And standard deviation was, what was that, 51.96? And so we have a less than 1% chance that they would exceed the maximum capacity of the elevator. All right, so that is it for reviewing for the test. Make sure you go through all of the questions at the end of chapter 6, and good luck.